Hello everybody, we're going to go through a couple of proofs here that have to do with segment relationships. Let's look at number one. We're given that BC is congruent to DE, so I'll put a little tick mark there just to show those things congruent. We're to prove that AB plus DE is equal to AC. Okay, now almost every time our first reason in any proof, BC is equal to DE, that is a given. The next statement has to do with the segment addition postulate. That allows us to write that. The only segment addition postulate that where it could be applied is segment AC, and if we say AB, let's get this written here, a segment AB plus segment BC, that's going to equal the entire segment AC. That is how the segment addition postulate works. Okay, and then now what we have here in our last statement, AB plus DE is equal to AC. We are going to use substitution. If you look what happened here, we just swapped out this BC quantity, but our first statement up here says BC is equal to DE, so that allows us to make that substitution. Okay, then number two, given Q is between P and R is between Q and S, PR is equal to QS. So this segment right here is equal to this segment right here. And that's what we have when we are given that. Q is between P and R, as it says in the first statement, that is given. And then we say PQ plus QR equals PR, and that is the segment addition postulate again. Think of the segment addition postulate as a little piece plus another little piece equals the big piece. That's what we're talking about up here. R is between Q and S, that statement is given. And then we have to apply the segment addition postulate again here to fill in this fourth reason, this fourth statement. And the other one we haven't addressed is QR plus RS is equal to QS. And that again is the segment addition postulate. Now for E, PR is equal to QS, that is a given. That's the last item that's given. So see, your given statements don't always have to be right in a row. A, C, and E statements are given. They're spread out here. For F, we're just going to say PQ and QR is equal to QR and RS. That's combining these two statements here, the B and the D statement. And then we can set those two quantities equal to each other because of the E statement here. So what we applied here was substitution. Just to abbreviate that. And then as it looks, we took this equation and it looks like they subtracted QR from both sides, as you can see here. So here we're applying the subtraction property. If you subtract from one side of an equation, you subtract from the other. And then finally, our last statement is what we're trying to prove. And then it follows from G. After you cancel out the QRs, you are left with PQ equal to RS. And there you go.